Now, SHM. So we realized in the last class that the biggest thing, if you find the net force after disturbing a body from equilibrium, which kind of equilibrium it has to be, stable or unstable or neutral? Stable equilibrium. If you disturb a body and gently and give it a small displacement and then you find the net force, will this net force include the force exerted by you? Will this net force include the force exerted by you? No. You will displace it gently from the equilibrium position and leave it. Once you have left it, then you find the net force. If this net force is proportional to what? Displacement from the mean position linearly. Linearly means x to the power 1. And if it is oppositely directed, then we say the motion is going to be harmonic, otherwise not. How many of you are clear about this? So this is, if I have net force is this, then the acceleration will be equal to some constant. Now if you write acceleration as d2x by dt square, this will be equal to minus cx. Now I can integrate this. I can integrate this equation. I have told you finally the solution will be, this is a second order differential equation. But you can do it by integrating it step by step. Suppose this is like d by dt of this, d by dt of this. Now d by dt of this means I can multiply it by dx up and down. So I'll get dx by dt. And this will be d by dx. I can do this. All this is a part of your calculus which you will learn at a later stage. I wanted to avoid it at this stage, but still you should have a rough idea. Now, dx by dt is what? Velocity. Dx by dt is velocity, v. So you will have, and dx by dt here also it is velocity. So I can write this is v dv by dx. Acceleration can always be written as v dv by dx. This is equal to minus cx. And if I take dx this side and I integrate these two, I will be able to integrate these two, yes or no?
Yes, sir.
And I'll get a relationship between x and v. I'll put the limits. X varies from which value to which value, velocity varies from which value to which value. And then once you have velocity as a function of x, then you can write velocity as dx by dt. So finally you will get x as a function of time after another integration. Suppose here you get v square by 2 is equal to minus c x square by 2 plus some c2, some constant of integration, which you can find. Am I right? On integrating these. Now once you have found v, if you write v as dx by dt and this right side function will be in a function of x, and then you integrate, you will finally get x as a function of t, and that function will be of that form only जो हमने कल सीखा था. What was that form? X is equal to what? A. It will be in this form. So this is the solution to, if you remember the last class, please walk in. So you will realize the general equation representing a simple harmonic motion, the display, where x is what? Please tell me all of you. X is what? Displacement from the displacement of the particle undergoing SHM from the mean position. What is it?
Amplitude.
What does amplitude mean? Maximum displacement from the mean position. What is omega? Is it angular velocity or angular frequency? Angular frequency. And does it have any connection with angular velocity? We did the relation between the circular motion and the SHM. Did we do that?
Yes, sir. Yes, sir.
So we realized when a body is moving in a circular motion, then the foot of the perpendicular from that body on the diameter performs SHM, right?
Yes, sir.
And the angular velocity of the body, constant angular velocity in the circular motion, has a connection with the angular frequency of the SHM, and here it is called angular frequency. What is phi? Initial phase. Phi is not phase. Phi is what?
Initial phase.
Initial phase. And what is omega t plus phi? This whole thing is called what?
Phase change.
No, it is phase at time t. Phase change nahi hai. It is phase at any instant. Phase at time t. Phase difference, phase change, वो अलग चीज है. Phi is called initial phase and omega t plus phi is called total phase at time t. Now, I just want you to get a hang of phase. Now, I'll give you a physical situation and you have to tell me what is the phase. What is the initial phase? This integration and all is given in the book, so I'm not like making you copy it or be rigid about it. Just see this. If suppose I have a simple pendulum hanging here, can you tell me if I hit it here with some velocity it starts going? Can you tell me what will be the initial phase?
0.
Suppose I pull it to some angle theta naught and then I leave it. Now tell me what is the initial phase? T is equal to 0, it is here. यहाँ से शुरू कर रहा है. So what is the initial phase?
Depending on some positive ले रहे हो negative.
Yes. First thing is you have to decide what is your convention. Please see this. Suppose you have chosen this to be 0 angle. This is the equilibrium position. Now suppose you have chosen anti-clockwise to be the first positive cycle. Suppose this is a circle. In this circle, suppose I have decided that when a body will move anti-clockwise, I'll take the angle 0 here. Here it will be 0. And when it will go any position, I'll take anti-clockwise angle to be positive. So obviously I'll say initial phase is this. If the body starts from here. If the body starts from here, initial phase is this. If the body starts from here, initial phase is pi by 2. And if the body is here, initial phase is 3 pi by 2. If anti-clockwise has been chosen positive. So now you have to tell me in this case, if I choose the anti-clockwise motion, the clockwise motion to be positive, what is the initial phase? I have chosen clockwise motion to be positive. Initial phase is how much? No, theta naught is the amplitude. It is not the initial phase. Please understand the difference between phase and amplitude. It is the angular amplitude. Theta naught is not phase. Very wrong confusion. It can be a very intelligent IIT question, objective. Theta naught is not phase. Theta naught is the angular amplitude. Maximum angular displacement from the equilibrium position is theta naught. Please tell me what is the initial phase if I leave the body from here and I have chosen clockwise direction to be positive. Clockwise motion.
We've already taken theta naught is the amplitude that.
Amplitude, yeah. It is displaced by theta naught and from here I am leaving it. So it starts falling down. So tell me what is the initial phase. If I leave it from this side, either minus pi by 2 or 3 pi by 2. For phase, we are going to confine ourselves from 0 to 2 pi. Instead of going minus pi by 2 to, we should say what? See, please understand what is the meaning of this. How many of you are getting the meaning of phase? How many of you are not getting? Not getting, wale haath uthaiye. Honestly. Good, good. I admire the honesty. Now please pay attention. Please remember this. This will help you. If this is a circular motion, this is that diameter on which this is suppose the initial reference line. Suppose the circular motion, a person is doing a circular motion and the foot of the perpendicular is here, F. Initially the foot of the perpendicular, tell me, person P is doing SHM, yes or no? Acha, acha. Person P is going to move on the circumference of the circle with constant angular velocity omega. Is person P doing SHM, yes or no?
No.
No. Person P is doing circular motion?
Yes.
Person P is moving with a constant angular velocity?
Yes.
Person P is doing a periodic motion?
Yes.
Person P, if I drop a foot of the perpendicular from P on the diameter, vertical diameter, if I drop a foot, so tell me, is the foot of the perpendicular doing SHM, yes or no?
Yes.
So the foot of the perpendicular is doing SHM. Tell me, if P starts from here, the foot of the perpendicular starts from the equilibrium position, yes or no? If the person starts from here, the foot of the perpendicular is starting from one extreme position, yes? If the person initially is here, where is the foot of the perpendicular? Here. If the person is at this place, the foot of the perpendicular is also at this place. Do you understand this? Now, if the man starts his circular motion from here, then at t is equal to 0, what is the phase? What is the initial phase? This is the reference line. The foot of the perpendicular is at its equilibrium position. Now tell me, what is the initial phase for this man? What is the initial angle that this man is making with the reference line?
0.
So what is the initial phase for F? 0. If the man was starting his motion from here, suppose, and this angle was 30 degrees, can you tell me what is the initial phase? Please respond, everyone. What would have been the foot of the perpendicular would have been here, and it would have been going this way, and we would have written that the initial phase is 30 degrees or pi by 6 radians. Am I right or not? If the person was going to start from P here.
Yes, sir.
Do you understand this? Now, so if a particle is starting SHM from if the particle is starting from equilibrium, then the initial phase is
0.
if it is starting from extreme, then either it is pi by 2 or 3 pi by 2. So now, if it is at equilibrium position, then either 0 or pi. There are two solutions, either 0 or pi. Because when this person will rotate pi and reach here, again the foot of the perpendicular is at equilibrium position. Are you clear? But now it will be, the foot will be going in opposite direction. So 1 minute, now answer. Please tell me, I want to correlate the motion of a pendulum or simple harmonic motion of any nature, simplest nature let me take,